Hey guys, this is Ms. Mo. This is 12.4. 12.4 is about similar figures and using proportions. And first off, a similar figure obviously looks similar. So if you look at this little chihuahua and the big chihuahua or whatever this is, these are similar figures. They look similar. But in math, we go a little further. And we say that these two shapes are similar if they have corresponding angles that are congruent. So maybe the way this right hand ear opens is the same way this right hand ear opens on the other chihuahua. They're the same angle. Yeah. But with similar figures, their corresponding sides are proportional, as in they're scaled or multiplied by using a scale factor. So if you look at these two little chihuahuas, yeah, their ears open at the same angle. Whatever that is, maybe 30 degrees, 40, I don't know. So their ears open at the same angle. But if you look at the length of the paw, this little paw is like, this paw is a little bit bigger. So, similar figures have matching angles or corresponding angles that are congruent. That means equal. And their sides are proportional, as in they're not the exact same number, but we can multiply or divide to get the sides. So angles are equal, sides are similar just by multiplying. Okay, so let's look at this picture right here. You might not can see it, but there's two triangles. And they are similar if they have matching angles and if their sides are proportional. Let's see if their sides are proportional. That means we look at the same side of each figure. So if I'm looking at these two triangles, let's look at the hypotenuse, 6. And how do we get to the next hypotenuse on the bigger triangle, 30? What do we have to multiply by? 6 times what gives you 30? You have to multiply by 5. That's how we get 30 right here. So, this picture has a question mark on the bottom of this triangle. Well, let's think about this. If you have to multiply by 5 to get the big triangle, the question is, what number do I put on the base of this smaller triangle so that when I multiply by 5, I get 25? So, what times 5 gives you 25? And the answer is 5. Yeah. So the length of the bottom of this triangle would be 5. Let's see the up and down part of the triangle. It's whatever times 5 gets you this 20. So we look at the heights, and one of the heights is 20. I know that this smaller height is whatever times 5 equals 20. So what multiplied with a 5 will give you a 20? And the answer is 4. So 4 should be the height of this thing. So the sides are proportional. We know that 2 of their angles are equal. Yeah. And on this picture, it would say these two triangles are similar. Yeah. Okay, so your homework, these pictures, I didn't write down what your homework will say, but your homework will say these two are similar, and they'll have like these little hoopty things across the angles so that you know that the angles are the same. And this picture did not have that. Okay, let's look at this next example. Here's 2 more triangles. Let's see if we can figure out what the scale factor is. So we want to know How do I get from 8 to 16? What do you have to multiply by? 2. Well, that means that my hypotenuse of 10, to get my new hypotenuse on my bigger triangle, I should be able to multiply by 2. So 10 times 2 is the 20 I have on my hypotenuse. Let's look at the base of these triangles. If these are similar, then that means the 6 multiply 2 gives you this 12. And it does. Okay, so that whole multiplying by 2, that's called the scale factor. We'll learn that in a minute, but that's called the scale factor. Or on this example with the tree, the scale factor was multiplying by 5. Okay, and on your homework, when they say that things are similar, they'll talk about the shape, triangle, ABC, triangle, blah, blah, blah. And then that little symbol in the middle, it looks like a dash but wavy. I don't know what it's called. Anyway, but that symbol means similar. So if we see this symbol on our homework, that means the sides are proportional. And we can do that whole multiplying thing. Okay. Same thing with this picture at the top right. Just because it's a crazy looking picture does not mean that it cannot be similar. As long as the sides are proportional and the angles are equal, these two figures should be proportional. So I would check. I would say 4 times who gives you 8? Times 2? Well, let's check all the other corresponding sides are the same way. If we look at this up and down piece, 1 times 2 should give me this 2 I have. Or this 6 along the bottom, 6 along the bottom, times 2 should give me this 12 along the bottom. Okay, I think you get the point. So, the next question says, this is a homework problem. It says, are the given rectangles similar? Tell why or why not. Well, first, look at the top right angle of this big rectangle. Look at the top angle. It's a right angle. So is the bottom right. And the top left, and blah, 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 blah. Okay, now look at the smaller rectangle. His angles inside should be 90, 90, 90, 90, because matching angles are equal. Okay, so, since they do have those little boxes, we know that all those angles are 90, all the angles in the big rectangle are 90. So let's check to see if we can, use a scale factor for their sides, and if we can, then that means yes, they're similar. Okay, so we got 2 rectangles. We got this big rectangle, it looks like 19 across, but how much is up and down? 19 is across. Up and down is not just this 2, it's this 2 plus the 2 underneath it. Oh no. Okay. Then let's look at our smaller triangle. Our smaller triangle has 9.5 on the top, and then its height is just 2. Okay, the question is, are these proportional? Well, we have to check and see. Okay, if I go from the smaller to the bigger triangle, the same sides, the up and down, what do we have to multiply by? You multiply by 2. 2 times 2 is 4. Let's check. Let's see if 9.5 times 2, let's see if that's 19. And holy goodness, it is! So, the question is, are they similar? Well, their angles are congruent, as in their matching angles are equal, and then their sides are proportional. Its scale factor was a 2. To get from 2 to 4, we multiply by 2. To get to 9.5 from 19, or from one to the other, we got to multiply by 2. So the answer is yes, they are similar. So goodbye B, D, E. So yes, they're similar, but we need to figure out why. Well, they had those corresponding congruent angles, and they had sides that were proportional. Let's see what says what. Part A says the okay, it has the congruent corresponding hoopla, but then it says do not have proportional sides. That's a lie. Ours do have proportional sides. That means to get from one to the other, you multiply by 2. 2 times 2 is 4. 9.5 times 2 is 19. Okay. So we need the answer choice C that says, yes, they're similar because the angles are congruent and the corresponding sides are proportional. Look for the answer that says R. Okay, let's look at the next sucker. These just say find the scale factor. And I think I'm just going to say they are similar. Your homework has a lot more words on this question, on these questions, but we're going to try and make it smaller. Okay, so we're going to pretend that they're similar. I think the words in your homework tell us. I just didn't copy and paste it. Now we need to find the scale factor. So we're going to look for two sides of the same triangle. Okay, so I see this 4 down here, and I'm going to compare it with the 7. Because those are the same sides of the triangle. So how do we get from 4 to 7? That's kind of weird. Okay, well, let's think about this. 4 times something gives you 7. Okay, we're writing it kind of like a little kid would. Okay, well, if I want to get rid of that question mark, if I want to get rid of the 4, and if I just want to solve for that question mark, what's the opposite of this multiply dot 4? It's divide by 4. So question mark is equal to 7 over 4. Or if you had no idea what had just happened, let me use an X. I could say 4 times something we don't know should give me this 7. Okay? Then, to get X by itself, we divide by 4. And hot sauce, that's where we got X equals 7 over 4. So the question was, find the scale factor. Here it is. 7 over 4. And then I think your homework also said something about it labeled the triangle according to what they were in terms of side angle. Okay, so let's label these triangles. I give you a side. Nope, my bad. I give you an angle. So the 33 is an angle that they gave you. The 66 is an angle that they gave you. And then the side that they gave you is that 7. Okay, so I either call it AAS or maybe SAA. Woohoo! Okay, let's look at this second example. Okay, this second example, let's find the matching pieces, because then we'll be able to find the scale factor. Okay, so let's look at this big old guy. Yeah, this big old guy, this big triangle. Okay, if I were to take this smaller triangle and kind of turn it around and rewrite it so that it's kind of next to this big triangle, let's see what I would have. The right angle is definitely B. The right angle is definitely B. Okay. Along the, let's see, the hypotenuse is AC, so I either need an A here or a C here. We just have to figure out which one. Okay, well, let's look at the angles. We know that those right angles are the same, but let's look at this. It says this sucker is congruent to this sucker. Yeah. Okay, so that means that the 6 that I'm going to label is going to match with this 12 that I'm going to label. So they gave us the 2 angles, but if I took this triangle and I just spun it around, okay, it's supposed to look like this, with 2 at the top, let's label it 2 at the top, and where was that 6 at? The 6 was not the diagonal piece, it was the up and down piece. So I'm saying if you take this triangle out and you kind of rotate it around to make it look like the bigger triangle, like shaped like the bigger triangle where the right angle is in the top right and the matching angles are in the bottom, that's all I did. Okay, so now the question is, what's the scale factor? Okay, well, let's see here. To find the scale factor, we look at 2 matching pieces. Well, I see from 4 to 2. And then I see, what else do I see? 12 to 6. That's not my phone. So 4 to 2 and 12 to 6. Those are the proportional sides. Because again, if you take that tiny triangle out and you rotate it to make it look the same, the 2 is on the top. Okay, so to find the scale factor, we're going to say 4 times what gives you 2? Or 12 times what gives you 6? Okay, so this one's a little tricky. If we're going from the big triangle, and again, the big triangle is ADE. So on your homework, if we're talking about triangle ADE and triangle ABC, that tells us where to start with and where to go to. So if ADE was 4, how do we get to 2 of the ABC? Well, we have to divide. So your scale factor would be, you have to divide by 2. Because how do you get from 4 to 2? Or how do you get from 12 to 6? You have to divide by 2. So the scale factor would be 2 here. Unless we went bass-ackwards and we started with triangle ABC and ended up at ADE. So your scale factor can change sometimes. It just flips upside down. So let's say I started with triangle ABC first and then triangle ADE. Well, pick the number from ABC. Here's my ABC, 2. And we're asking, how can we go from 2 to the bigger triangle with the ADE? 4. Or how do we get from 6 to 12? Okay, so that scale factor is for sure 2, because to get from 2 to 4, we multiply by 2. To get from 6 to 12, we multiply by 2. But if you look at this one before, I also wrote 2. That one's not quite right, because let's think about this. When you take half of something, you're not multiplying it by 2. When you take half of something, you're multiplying it by 1 over 2. Yeah. So when we went from the big triangle to the smaller triangle, we multiplied by 1/2 because we got smaller. Vice versa, if I'm looking at the smaller triangle and then the bigger triangle, I multiply by 2 because I got bigger. Okay, let's keep going. Let's look at this bottom left.